Okay, so today we'll discuss about output modes, different output modes supported in the Spark structure streaming, because this is very important. Based on this, there are you will see the result of your data coming out of your Spark streaming. So, and also there are certain features which is supported based on this output modes. Okay, so whether you can write aggregate queries or not, which output mode supports aggregate queries, and if doesn't support, what is a workaround. So those are the things all depends upon the output mode. So yesterday I told you there are three types of output mode. One is complete, okay, and another is append, and the third one is update. Okay, so let me get the documentation as well. Okay, so as I told you, append, complete mode, update. Okay, so append is the default. If you don't provide any any what to say, you don't provide if you don't provide the output mode or in your sync. Okay, so basically we are using console sync in the previous example. If you don't provide any sync, then it's going to be a default. It is
Hello. Hello.
yes.
I'm not able to hear you, buddy.
Okay, yeah, I was in mute actually. Okay, so so default output mode is a append. Okay, and you can choose other output modes like complete, update based on your requirement. Okay, uh, and there are certain things which is supported in the output mode. All these metrics are available here. Okay, now we'll go and check what is the difference between different output modes. Generally, append mode is more of insert. Okay, any new records, so your aggregate queries or your final result will reflect. Okay, so all the operations are based on the new record which is coming in the streaming. Whichever the data, the whatever query you write, it is going to applied on the new data which is arriving in your streaming system. Okay, and complete mode is you are going to apply the queries on all the data which is come from the different time intervals. It's always going to work on the entire data set. Generally, the complete mode is uh, what to say, not advisable to use complete mode, because it has to apply on the all the data set which is it is not possible on certain after a certain period also. Okay, so there are only few scenarios where you can uh, uh, apply the complete mode. Okay, because it has to go and work on the entire data set, which is we may get some uh, issues, out of memory issues, when the data is very huge. It is when it is cumulated to huge number of data, then it is huge. Then the update mode. Okay, so update mode is more of a new data, uh, so new data and also updated data. Okay, which means it's going to be a kind of upset. So it is going to work on the new data, and also if any data is updated, okay, then it is going to uh, work on that. If any data which is not updated, it is going to ignore it. Okay, I will tell you the example. Okay, so these are the three difference of modes. So let's get into the IO complete mode. We already saw. Okay, let me even will just run the complete mode first. We'll take this example. Okay, so this has been explained in the three time intervals. Okay, this is time interval 1, and this is time interval 2, and this is time interval 3. Okay, so in the time interval 1, what is the input record which is received? It's, you can think this is basically a word count program. Okay, you received the uh, uh, the records like Scala, Spark, Scala, Kafka. Okay, so then this is your input table. Okay, then what we made is basically we made the result table. Okay, so we did try to do the uh, word count. Okay, we just split it by space, and then we just do the group by count. When we do this, so we got Kafka one time, and Scala twice it occurred, and Spark is once. So this is the result table which is formed in the time interval 1 or the trigger interval 1, right? So when the trigger interval 2 comes, right? So what happens when the trigger interval 2, you got a record saying Scala and I, okay? And so anyway, the input table will keep uh, get accumulated, okay? And when you apply the incremental queries, so what happens basically when you do the word count, so what is happening? So we see the key, there is a this record Scala I is there, okay? So Scala is a coming and Hive is coming. So there is no Spark word is coming in this time interval. So in your result, so what you are going to see is you are going to see the, since this is the output complete output mode, you are going to see the entire data set. You see the word count for all the words. Okay, so Kafka once and the Scala is once. Okay, so this what is 30? Okay, so Scala got incremented to 3, which was 2 in the previous, 3 and Spark once. Similarly, in the third time interval, you're getting one more record, Spark Kafka. So it is going to increment the Spark one more time to 2, and Kafka it will increment to. So complete mode, always whatever the records there in your input table over the period of time, it is going to do the aggregate on that. It is going to give the result. It's almost it's straightforward. So whatever it is accumulated in the input table, it is going to do the aggregate. That's what we see in the previous when we ran the yesterday also we saw, right? So let me show you that. So here I'm set the mode as complete mode. Let me run this. So I will pass the same Scala Spark, Scala Kafka. I will pass it as, so this is RAM. Scala, what is the input? Scala Spark, sorry, Scala Spark and Scala Kafka. Scala Spark, Scala Kafka. So this is, take example of, I just published these two records. Let's see the output. The 0th batch, it did not receive it. Let's wait for the next batch. And after that, what I'm going to pass this, I'm going to pass Scala and I. Sorry. Scala and I. So this is the next record. So Scala and I, so this has to be incremented to 3, and you will have one more entry. Right. Yeah, so we got it. Now in the third batch, what let me close this. Okay, so in the third interval, I am just going to pass Spark and Kafka. Spark and Kafka. Okay, now it is going to increment Kafka to 2 and Spark into 2. Yes, Spark is incremented to and Kafka is incremented to 2. Okay. So this is how the output mode works. Now let's see the update mode. Okay, this is a complete output mode of result. Let me stop this and let's go here. I just create make it as update. I will make it as and let's see the other output mode as well. So now I will open the update mode. I'll go and change this output mode to, instead of complete, I'll just change it as update. Okay, I will run the program again. Okay, so I'll just again, this is Scala Kafka. This is the first time interval. Just going to pass Scala Kafka, sorry, Scala Spark and Scala Kafka. So these two records I am passing as a first batch. Okay. The second batch I'm going to pass Scala type. So here you see this two entries there. Okay, actually it got splitted into yeah. See here it actually got split into two batch, and the first batch only first record was split. Okay, which is like a Scala Spark. Okay, and the second record was picked in the second batch, and since Scala is updated and Kafka is a new record, okay, so these two are picked, and it ignored the Spark because Spark it considered being it's not updated or it is not a new record, so it ignored the Spark in the output. So this is how basically uh, the output mode update works. So now actually I'll update one more, I'll put one more record Scala high. Now you should see the Scala and high. It will ignore Kafka also. So update mode is always it will reflect the updated record as well as the new record. So it will ignore the record which is not updated. See here now, Scala got incremented to 3. It ignored the high. So run the last one also, last record. So this time, the previous output, what was this? Scala high. Here what we passed, Spark Kafka. None of things are there. Just ignore these two also. Okay, so from the previous one, actually the hive is not updated. Okay. Yeah, hive is not updated. Here, Scala and Spark and Kafka was there. Scala and Spark. Any question on this?
No questions.
Okay. All right. Okay, so this is how update output mode works. Now let's run the third output mode, which is append. So it's always insert. So let me run this. Let's stop this. I'll publish the first record, which is Scala Spark and Scala Spark and Scala Kafka. Did I change? I'm sorry, I have not changed this. You have to change the mode to append. I'll run this. PySpark. So you see this error, there is error saying this is what expected. Append mode not supported when there is a streaming aggregate on a streaming data frame or data set without watermark. So we said append is basically always a new record, right? So basically, so whenever new records come, if you want to do aggregate, it's not supported in the append mode. So what we need to do is the workaround is you need to use the something called watermark. So we will discuss that in the later stage. Okay, so basically we complete some of the data source and sync, then we'll go for watermark. So for now, you can think you cannot out of box you cannot apply the streaming queries on the when you use append mode. Okay, so workaround is you have to use a watermark. Okay, so aggregate in append output mode, aggregate queries are not allowed. Okay, for now you can just keep it in mind. Now I'll just focus on the next topic. Which is going to be a file stream. Okay, so let's use some. So file source in Spark structure streaming. So file sources are read files written in a directory as a stream of data. So when we have when we use a batch API like read the data and make it as a RDD or read data from the static files from the directory and make as a data frame. So that is the one way to do it. Okay, so when it comes to Spark structure streaming, so what we are going to do is we are going to consume the data from the same particular directory, HDFS or S3 directory or even the local directory. So what it is going to do is it's going to read the data as a stream of data. So if say example, a particular directory you are reading. So it has a time interval 1, there is a file. File 1 at file underscore file say customer underscore t1 dot txt. Okay, so you are reading a text file. So at time interval 1, you are reading a customer data and you are making some aggregate. Okay, at time interval 2, you are getting customer underscore t2 dot txt. So first it will read the first file which is there in that directory, and when it comes to time interval 2, it is going to read the customer underscore t2 dot txt. It will not again read the customer underscore t2. So it will take care of all those things. So ideally it is going to read the files in a directory as a stream of data. So file will be processed in the order of file modification time. If the if lot first is set, order will be reversed. There is option to change order of data. Okay, so the supported file formats are text file format, CSV file format, JSON and ORC and parking. These are the file formats, 5 file formats which is supported in the file source in a Spark structure stream. So we'll see example. So the overall picture is, so you will have directories which has certain file formats. So that will be read as a stream of data. Then you can, once you process, you will see the result, something like this. Okay, Kafka will see. So let's see the example for these file sources. Okay, so text file I did not put since it is it's going to work like CSV. So we'll start with the CSV. So I also have a batch API program. Let's show you the batch API program. So what do you do? I think we saw in the previous example. So when you have a data in a particular directory CSV file, so we say Spark session object dot read dot and the format of CSV, and we provide option if it is any option is needed, like header is there or not, and we'll say load. So whatever the files, CSV files exist in this directory, it is going to load and convert this as read, and it is going to convert it as a data frame. And then you can apply the operation. Now let's see the same CSV file source in terms of how do you read it as a stream of data. Okay. So we here also we just create a Spark session object. Okay, so we need to create a schema. Okay, so we know like it's based on the header. Sorry, based on the your column headers, you are going to prepare the schema for it. So in this example, so what did I do is data. Yeah. I will just open this directory. Yeah. I will show you the input format. So it is basically if somebody sign up on particular website, so all the data is captured here, like registration, date, time, ID, first name, last name, and personal information, and some geographic information and other stuff. So this is a simple user or user registration screens or data captured records. Okay, so I just put it on two files. It's going to read this file path. So I'll just take it out from this directory. I'll keep it here. And now input data CSV, I'll just keep it empty. Okay, now let me maximize this. So I just created a Spark session object and define the schema for based on your input data. So you know how to create a schema for your input data, right? So basically you need to create a stack type of multiple stack fields. Each stack fields refers to the what column. Basically, you need to define the data type and whether it is nullable is allowed or not. Column name. Then this is the reading file stream of a file format CSV. So Spark session object dot read stream. Generally for batch API we put read. That's what we see here. In a streaming API you say read stream, and format a CSV, same option, and we provide the schema, and load off you provide the path. So that's it. So it's going to keep listening into this particular folder whenever new data arrives on particular interval. I'm not providing any trigger interval. So as soon as the data arrives, if you don't provide the trigger interval, as soon as the data arrives on this directory, it is going to process. Okay, so this is one thing. So let me run this. So what is the sync? I think console sync I'm using it. It's going to be how you read from a normal CSV file. Okay, if I think only 1 minute left. If disconnects, please rejoin with the same link. Okay, so now let me put my file there. So I'll just go one back. Copy the use file. I'll paste it here. Now the data is placed in the input records. So it is going to